Hello guys, welcome to my channel RKG Tutorials. Now we are in the third class. In the previous class we have studied the applications of the power electronics devices, power semiconductor devices, nothing but the power processing circuit. We have seen different applications. Now let us get into details about the power semiconductor devices. What are the different types of power semiconductor devices we discuss? Actually, today we are going to discuss one of the most important topic called switch. So why we need to learn the switch before the power semiconductor device, that we will see first. As we have already discussed in the previous classes that power processing circuit is the most important part of the system that increases the efficiency. The power processing circuit consists of power semiconductor devices. So power semiconductor devices, what is the function of those power semiconductor devices? The function of these power semiconductor devices is similar to the functions of switch. So that's why it is more important to learn first about the switch before going to the power semiconductor devices. What are the characteristics of a switch and what types of switches are there that. So without wasting much time, let us directly get into details about the switch. So what is a switch and what it performs? Let us see. What is a switch? What is the function of this switch? Let us discuss. I think everybody will be able to say that switch is a function which performs on and off operation of the circuit. Or in other words, we can say it open circuit and short circuit the circuit, or it can connect and disconnect the circuit, or it can make and break the circuit. So all comes under the same function, all comes under the same meaning. So let us talk about the types of switches today. So there are basically two types of switches are there. First one is ideal switches and practical switches. First one is ideal switches and second one is practical switches. Today we will discuss about the ideal switch. If you able to find what is ideal switch, then automatically you will be able to find what is a practical switch mean. Actually, ideal switch, let us keep heading ideal switch. Ideal switch. Let us talk about it. So ideal switch is a bimetallic stable element. It is a bimetallic stable element which performs on and off operation. So we can analyze the ideal switch based on five factors. First one is on state. Second one is off state. Third one is transition state or transition behavior of the switch. Transition state or transition behavior of the switch. Fourth one is external circuit requirement. External circuit requirement. And finally, fifth one is thermal stability. So let us talk all these parameters with respect to the ideal switch now. You might be knowing what is on and what is off state. First, let me give a small glimpse about on and off state. Let me draw a switch here. So this is a circuit, and here we are placing the switch, and here this is a switch, and this is through, and this is pole. This is through and this is pole. Let us take one more for the off position as well. So this is through, this is pole. What happens during this? So we are talking about on position. When we are saying a switch is on, then what will be? It should short circuit the network. So through should connect to pole and will become short circuit here. When it is short circuit, what it means? There is a flow of current. I must be flowing. And what happens to the voltage? The voltage will become 0. And next, if you are opening the switch, that means from pole we are taking it to through position, which means it is opposing the flow of electricity, so that we can say it is open circuiting in during the off position. Means the whole uh, voltage will be appeared across these two terminals, across the switch only. So that is what is. So here V will be maximum, here I will be maximum. So this is on state, this is the off state. Let us discuss in detail about each and every state now. So let me take one more slide. Yes. So let us discuss first about the on state. Let us discuss about on state first. Yeah. So what is on state? Just now we have discussed that during on state, we are making the switch on, means we are closing it into short circuit. During the short circuit, the I is going to be maximum. Since it is the ideal switch, this can be infinite maximum. The voltage, the current can vary from minus infinite to plus infinite. Whereas what happens to the voltage? Since it is short circuiting, the voltage gets equals to 0. As the voltage drop across this switch is 0, then what happens to the power loss? There will be no power loss. Power loss is equals to 0. The conduction power loss is 0 during the on state. I hope you understood the on state. Now let us go to second one, that is the off state. Off state. So as you understood this, automatically you will be able to understand this one as well. So this is the switch. So when we are opening the switch, so it is becoming open circuit, then automatically you will come to a clarification that here we are opening, which means what happens to the current? The current is getting 0. There is no flow of current during this. Then what happens to the voltage? The whole voltage appears across this, so the switch can withstand the voltage from minus infinity to plus infinity. So the voltage across this switch, let us say V off, I off, and here V on, I on. So voltage across the switch depends on the elements connected on the circuit. So here whatever the element connected, so depends upon the elements connected, the voltage get vary. But due to ideal switch, the ideal switch can withstand or it can bear infinite voltage. So the power also, what happens to the loss? Power loss. Since there is no flow of current, there is no power loss. So blocking power loss, there is no power loss. Now let us get into the third, that is the most important of this topic, that is transition behavior. Transition behavior of the circuit switch, ideal switch. We are talking about the ideal switch. Yes. So let me draw the waveform here first. Here let us take this is voltage across the switch, and this is current flowing across the switch. Yeah. So here during on state, what happens? During on state, what happens? Let us first talk about the off state. During off state, what happens? There will be a maximum voltage, and when it comes to off state, when it comes to on state, this is the off state. Voltage is maximum, but the current is going to be 0. And during on state, what happens? The voltage immediately becomes 0. This is the on state, whereas the current rises and current increases to a maximum value, and it flows like this. And here if you see, there will be no delay here. There is no delay. Immediately it falls back to 0 when it is off state. When it is in on state. This is the on state, this is the off state. So this is also off state, on state, on state. So again, if you go to the off state, if you off the switch immediately, the voltage across will be maximum and the current drops to 0. So this is what happens. So this is what happens when the switch on and offs without any delay, you can say. So this is the transition behavior. Transition behavior is a time. It is a time taken from on state to off state. Since if our switch is at off position, now we wanted to on the switch, then there should not be any transition delay. The turn on transition, we can say we are owning the switch, so the turn on transition will be equals to 0. Or if you go to the next, if your switch is in on state, if you wanted to off the switch, that becomes turn off transition. The turn off transition also becomes 0. Immediately there is no delay. So what is the time taken to on the switch? Now switching time can be taken as turn on transition plus turn off transition is completely going to be 0. And what happens to the switching frequency? FSW, it is nothing but the reciprocal of the switching time, that is equals to infinite, which means ideal switch can be with infinite frequency. This is important. In the numericals you will not get the time, whereas sometimes he might give you this frequency, switching frequency, and he will ask you to calculate the energy and power loss. I hope you understand. So the ideal switch can perform infinite switching frequency. This is what is the conclusion here. And let us talk the next thing, that is external circuit. Let me explain here itself. Let us take one more slide otherwise, because we have 2 more points to discuss. So fourth one is external circuit requirement. External circuit requirement. So just now we have discussed that from off state to on state, there is no transition time. That means the energy lost during this position will be energy lost during the on position will become 0. There is no energy spent, so during this off state to on state, and as well as from on state to off state also, the energy loss will be 0. There is no energy loss. Since we are talking about the ideal switch, there will not be any energy loss during turn on time and turn off time. So E on is equals to E off is equals to 0. So there will not be any extra circuit needed in order to provide the energy to the circuit. But during the practical class, what happens? This should not be 0, this should not be 0. So there is a loss of energy. So in order to compensate the loss of energy, we have to use an extra circuit, an external circuit, so in order to provide that loss of energy. So to turn on and turn off energy, to turn on and turn off the ideal switch, there is no need of external circuit requirement. I hope you understand. And let us take one more let us discuss about the last property, that is the thermal stability. Thermal stability. Since we are discussing about the ideal switch, so it should have the capability to be stable, to be thermally stable for all operating conditions. It should be thermally stable for all operating conditions. Let us see the characteristics once. Voltage versus current. Voltage versus current. Let me take this as switch voltage. This can be switch current. Now let us see. So during on position, what happens during on position? The current increases, voltage becomes zero. The current increases till where? Just now we have seen I is in between minus infinity to plus infinity. So here somewhere here it will be, this is on the x-axis, somewhere here it will be infinite, plus infinity, and somewhere here it will be minus infinity. So this is the operating region. It can be operated all over the x-axis. This is during the on. This is during the on stage. And if you're talking about the off stage, the voltage becomes zero during, this is on state, this is off state. The voltage becomes infinite, so from minus infinite to plus infinite. So it will be somewhere here, this is plus infinite, and this will be somewhere here, that is minus infinite. So this is the operating region. So wherever the situation, wherever the operating condition you may take, wherever the condition you may take, where the ideal switch is thermally stable. So it is thermally stable in all the operating conditions. So this is what is the conclusion here. So thermally stable in all the operating conditions, for all operating conditions. So this is what is the discussion regarding the ideal switch. I hope you understand. Now we will discuss the practical switch in the next class. So that is very important. That is where the numericals are always asked every year. So we will discuss the practical switch in next class. Thank you. And if you're not yet subscribed, please subscribe and share the video, and like, comment the video if any problems. Thank you. Signing off.